Hey, everybody. Welcome to this webinar organized by JetBrains. I'm your host, Nafil Islam. Today, we have a really special guest today, Mike Driscoll. Mike has been writing Python books for a very long time and has been a part of the Python community for a long time. He's currently a software engineer at Pluralsight, and he's going to be giving us a talk on the Functools module, something very near and dear to my heart because there's so many cool things that you can do with it. So, before we get started on this, I just wanted to let you all know that if you have any questions, you can over here or here, yeah, there, over there, there are you can ask questions in the chat, and we'll be monitoring that, as well as on Twitch. Apparently, we're live there too. So, if you have any questions, we'll be able to see those as well. So another thing that people ask us is this session going to be recorded? The answer is yes. It will be recorded and it will be available immediately after this webinar is over. So without much further ado, please welcome Mike Driscoll.
Hello, I'm Mike, and as Nafil said, I'm going to talk about the Functools module, a really amazing module in Python. All right, just a little bit about me. I write about Python at Mouse vs. Python. As mentioned, I'm a book writer. I have 10 books out right now, most of which are self-published. Real Python lets me contribute to their website from time to time, so I have a couple articles on there. And I just wanted to talk a little bit about content creation because it's my passion. And I like to write about Python wherever I can. And so I've been doing a lot of that on Twitter and LinkedIn, and of course on these other websites. And I've been slowly adding neat tutorials to my YouTube channel. Anyway, enough about me. Let's talk about Python. Python has over 200 modules. It's awesome. And because it comes with so many modules, you can do most things out of the box with Python. Today, we are going to talk about the Functools module. It's got kind of a weird name, so let's figure out what is Functools to begin with. The Functools module is a collection of higher order functions, functions that act on or return other functions. So what that means is that most of Functools are decorators, because a decorator, by definition, takes in another function and returns a different function, usually without modifying the function that is decorated. In general, any callable object can be treated as a function for the purposes of the Functools module. All right, the Functools module has a bunch of different little items in it. We're going to try to cover most of them. It actually has three items in the caching category: cache, cache property, and LRU cache. Another interesting tool in Functools is total ordering. We're going to talk about partial, reduce, single dispatch, and wraps as well. I think you're going to find this really interesting. I know I always have fun playing with this module. All right, let's start with caching. So to me, 3.9 isn't that long ago. And so I just want to mention, when did all this get added? So cache is kind of new, came out in 3.9 in Python. Cache property came out in 3.8 and basically lets you add caching to your properties. And then you have LRU cache, which has been around basically for as long as Functools has been around, way back in Python 2 days. Let's talk about functools.cache though. So functools.cache is a simple, lightweight, unbounded function cache, sometimes called memoize. Now this comes directly from the Python documentation, so it's a little bit rough around the edges, and I'll try to explain, what this all means. But basically, what functools.cache does is it's kind of a shortcut way of saying LRU cache with a max size of none. This creates a thin wrapper around a dictionary lookup of the function arguments. Because it never needs to evict or remove old values, functools.cache is smaller and faster than just using LRU cache with a size limit. Sometimes I think this is a lot easier to understand if you actually see an example. So we're going to look at Python, an example from the Python docs. Okay, So to get access to the cache, you do from Functools import cache, apply the decorator to whatever function you want to add a cache to. In this case, I'm going to add it to this recursive factorial function. And then I'm just going to kind of walk through what's happening here because it's kind of hard to show in this code what's going on. So if you call the factorial with the number 10, and what this means is it's going to be like 10 times 9 times 8 times 7 times 6 all the way down to 1 is what it's going to do basically. The first time you call it, there is no cache. So this first time you call factorial is going to be kind of slow. So it's going to make a bunch of calls and none of it's going to be cached. But the next time you call it, you're going to call it with factorial 5, and it's going to just return that value immediately because it's cached. And then if you call a value that's above the cached version, it's just going to make 5 new recursive calls because it already has the first 10 cached. So factorial 15 will run many, many times faster than factorial 10 did. All right, let's try some other code just to kind of nail this home. First, I want to show you what happens when you don't have a cache at all. And we're going to use Python's timeit module to time how long it takes to run this. Fibonacci is a pretty common programming problem that a lot of people like to talk about, especially beginners. And it's a nice recursive function, and it takes a little bit of time to run. So just doing Fibonacci, we're going to pass in 35 as a Fibonacci number that it's going to try to calculate for us. And timeit will figure out how long this takes to run. So let's go in here. I'll go to run. And it's going to take a little bit while it thinks about it. And I think it'll take around 4 seconds. Yeah, 4.49 seconds to run this code. That's not great. Let's see if we can speed that up by adding a cache. To add a cache, all you have to do is do from Functools import cache, add the cache to decorator, and then just rerun the code. Let's see what kind of speed up we get by rerunning it. Remember, the first time we ran it without a cache, it took 4.49 seconds. As you can see, that number dropped dramatically. Now we're at 0.00022 seconds to run the same bit of code because we added a cache. That's amazing. You can speed up your code really quickly locally by using a cache. All right, let's talk about Functools LRU cache, which is very similar. Let's just switch back over here, grab our LRU cache example. This example is more interesting to me because instead of just doing a recursive function, we're going to try downloading web pages from the Python documentation URL. So here I'm going to use import time instead of timeit. We'll just kind of time how long it takes to download stuff. We'll use the URL lib module to download the HTML pages. And then we have this little function here, get web page. So the web page, it has a URL in it, and I just slap in whatever module code I want to grab. And then down here, we will try to read it and return it as basically text. If I happen to mess up with my module name, we'll get an error and return none. Up here, we have LRU cache with a max size of 24. What that means is that the cache will save 24 calls to get web page. If you get to the 25th call of get web page, the first item will be popped out of the cache to make room for the new one. The main reason you want to have a size limit is, all this stuff gets cached in memory. So you wouldn't want to download all 200 plus modules into memory unless you have a lot of memory, for example. Although I think most computers nowadays wouldn't have any problem with that, unless you have too many tabs open in Chrome, of course. All right. So down here to run this code, I just threw together some examples. We're going to loop over Functools, OS, sys, and OS a second time. The reason OS is in there twice is I want to see what happens when I try to call or download that module the second time. That should activate the cache, and we should see that it gets returned pretty much immediately. So to time this, we'll just loop over the modules for module and modules, start the time, end the time, and then calculate how many seconds it took to download that particular module's HTML text. Let's go in here and give it a run. Yeah, I get this sometimes. I'm not sure why it does that. I think the website that I'm connecting to has an issue. Let's try that one more time. There we go. So the first time through, Functools is 0.229. OS module is 0.32, so it's obviously a little bit bigger than Functools. Of course, OS module has a lot more data, a lot more functions and methods than Functools does. Sys module is actually smaller at 0.25. And then when we call the OS module a second time, you can see that it basically returns immediately. 0.0, let's see, 1, 2, 3, 6 zeros. That's a infinitesimally small number. So, you know, it's faster than the blink of an eye. It just returns that fast. I would highly recommend, and this is something I haven't tried yet, but it'd be really fun to put 26 items into this list and just see how the cache changes over time. And, you know, maybe just put in even OS module in there a bunch of times and just see how it changes when in its runtime. Anyway. All right, let's talk about our next topic, functools.total ordering. This one is one I don't use a lot, and I don't think a lot of people use it, maybe because they don't know it exists. But basically, given a class defining one or more rich comparison ordering methods, and by rich comparison ordering methods, that's a special dunder method, which we're going to get to in a second. This class decorator will supply the rest. It simplifies the effort involved in specifying all of the possible rich comparison operations. So let's talk about some of those. The class must define one of the following four dunder methods. Dunder LT for less than, dunder LE, which is less than or equal to, dunder GT for greater than, and then GE is greater than or equal to. So you can define one of these, and you also must define the EQ or equals dunder method. And then you can apply the total ordering code to your class, and it'll supply the rest. So how do we see that in action? I thought about this a little bit and decided, let's just write some code that doesn't use functools at all. So just for fun, I created a number class. It has an init dunder, which passes in whatever number I get. I just set it up in there. And then I just defined a couple of the dunder methods. So we do less than and return if that value is less than the other value. And we also do an equals thing. And just for fun of it, I'm messing this up. I'm just making it do the opposite of what it's supposed to do. Normally, when you define this method, you would do equal, equal. So, you know, play with that if you want. I'm actually going to leave it equal, equal, so it's less confusing. All right. So x equals 5, y equals 10 of my special number class. And then we're just going to try to compare them. And you'll note that I'm calling dunder methods that don't exist in my class. So let's see what happens when I run this code and see if I just get an error or something else. Okay, so let's match this up. The first one, less than, is true because we actually have it implemented and it's comparing the values correctly. Less than or equal to is not implemented. Neither is greater than or equal to. And the EQ one returns false because obviously 5 and 10 are different. So rather than adding all the boilerplate for the other dunder methods in here, we can just use total ordering. So to use total ordering, you do functools import total ordering, and we apply it to the class itself. Whereas with the cache stuff, the cache decorator, we apply those to functions. Here we're applying this decorator to the class. Otherwise, the code remains the same. So now when we run it, we should see that all of the other comparison operator or comparison special methods work, because now we have less than or equal to, greater than, GE, saying true, true, false, false, true, the way that they should, whereas before we had not implemented because obviously we hadn't implemented them. So this is kind of a shortcut. I think I've heard some people say this is kind of slower than implementing it yourself, like when you run the code, but it reduces development time. So there are trade-offs, just something for you to play with. I haven't actually timed it to see if it actually is slower to use this or not, though. So I don't know if that's just someone who likes to complain or if it's actually true. All right. Let's move on to partial functions. It's just like I'm thirsty. All right. So a partial function is kind of like a lambda in a way. They're used for creating new functions with defaults applied. I have an article about it on my blog at Mouse vs. Python, and I'm sure Real Python has covered this as well. Anyway, let's look at an example because I find partial code examples hard to explain without actually looking at the code. So to use it, you import partial, and you'll note that this time we're not going to decorate a function, we're actually going to call it. But in much the same way as a decorator takes a function, partial also takes a function. So the first argument of partial is whatever function you want to turn into a partial function. And then you can basically set defaults for different arguments within that function. So padd is now a function. It's a partial function. And every time you call it with a value, it's going to take that value plus the default. So let's see, we'll run this. It prints out 7 and 4 as 11 and just makes, it's kind of a shortcut way of just running a function in a special way. To me, this doesn't look real obvious. Why would I even use this? I've used it successfully when in GUI programming. So, stuff can be used, partial can be used as a callback in tkinter, for example. So let's just take a quick look at that. Here's an example of some tkinter code, tkinter being a graphical user interface for Python. Tkinter comes with Python, so you shouldn't have to install anything unless you're using the system Python on Linux or Mac. I don't think it comes with a system Python, but if you install Python separately, you should have tkinter. Anyway, normally without partial, you would create an event handler with a lambda, or you would just call the command. So in this case, if the command didn't take an argument, you could just say command equals button event. But my button event is special because it wants a label to be passed to it. So to make that happen, I use a lambda function and basically create an anonymous function that includes the label that is on the button and pass it along. Let's see. I just want to show you what this looks like before we continue. Okay, so we have some partial callbacks, but this one isn't a partial callback yet. Whenever you press the button, it prints out some text. Let's see how we can change this to actually use a partial function. So now we import partial, and instead we change the lambda to using partial. And I think a better example of this would be to actually have multiple buttons using the partial here. And I'm actually going to show you an example of that using another GUI toolkit. But to me, I find this code a little bit easier to understand than the lambda code. Now, that's probably just the way my brain is wired. But to me, that just makes more sense. And the code operates the exact same way as the lambda did, which is actually pretty easy to demonstrate. You just open it up, and you can keep hitting the button over and over again. All right, I believe I have a slide on here. Functool.partial can also be used with WX Python. Now, I think you could probably use it with PyQt or PySimple GUI or any of those other ones too, if you to do something similar. I just have a kind of a love for WX Python because I've used it practically since the beginning of learning Python. So I'm just going to talk about it a little bit. WX Python is cool because it lets you, when you run it, it uses native widgets. And what that means is that a WX Python application will look like it belongs on Mac or Linux or Windows because it's actually using the widgets that you would normally use if you're using a primary coding language for that platform. tkinter draws all of their widgets themselves, so it will look the same on all three platforms, which may or may not be what you want. However, Python has a lot more boilerplate. So we have this stuff here at the beginning where you basically create your frame and add a title. It's usually best practice to have a DebX panel which holds all the widgets that you have on your screen. And to make this more interesting to me, I went ahead and added 3 buttons this time. So we're going to loop over some labels. For each label, we'll create a button, add it to our panel, which is this widget up here. And we'll use our partial function to call our event handler on button and pass along the label. Now you might be wondering, what about event? You can see here that I'm not passing the event along. When you do button.bind, it passes event implicitly, which takes some getting used to because Python is all about being explicit, not implicit. But because we're using a C++ GUI underneath the covers of DebX Python, I think that's why event is kind of implicit here. Anyway, what I like about this particular bit of code is you can clearly see that we're passing a label along, and the partial function changes for each button that gets put in there. So this makes what's going on a little bit more obvious, at least in my mind. So you can see when I create this particular function, the buttons don't blend in with the background like they did with tkinter because they're actually using proper Mac buttons. And when you push the buttons, it knows that you're pushing the right one because of the partial function being able to pass along the correct label to the event handler. Most of the time, you don't have to pass extra data to an event handler, but there are times when it's really helpful, especially when you're debugging, if you have a really complicated UI. All right, let's continue on our Functools adventure. Functools.reduce. I found a great article on reduce on RealPython's website, but the documentation is really good too. What you might not realize if you've only been using Python 3 is that the reduce function used to be a built-in in Python back in Python 2 days. So you didn't even have to import it. But when Python 3 came out, I think there was some disagreement about how often reduce was being used. And so it got either removed or just moved into functools.reduce. I can't remember now. I think it was removed for like a version of Python, and then it got put back in functools.reduce. I'm sure someone will comment and tell me the history if there's someone watching this. Anyway, what it does is it'll apply a function of 2 arguments cumulatively to the items of an iterable from left to right, so as to reduce the iterable to a single value. Basically, it's kind of a way to cumulatively go over an iterable. One example that is on the Python docs is to call reduce with a lambda of xy, and then do x plus y, and then do that for each of these items in this list, which are iterable. What this does is equivalent to doing 1 plus 2, which is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. I'm going to show you some other ways to do that without using a lambda. Anyway, this comes from that RealPython example, and I think it's a little bit clearer description of how this all works. Apply a function or callable to the first 2 items in an iterable and generate a partial result. I think it's funny that they use the word partial here since functools has a partial function. Anyway, use that partial result together with the 3rd item or the next item in the iterable and generate another partial result. Repeat the process over the entire iterable until it's exhausted, and then return the single cumulative value. All right, let's take a look at an example of reduce. Just kind of nail this down. We're going to keep using our add function, and this time we're going to pass it to reduce. And we'll go ahead and do something similar to that lambda, but now we're just going to call add instead of the lambda, because before in that Python docs example, it was using a lambda function here that I thought was kind of confusing. I think this is a little bit clearer to run. Okay, let's go ahead and run that. And I went ahead and printed out what's going on so we can kind of see how reduce works. So the first time it runs, it calls it with 1 and 2. It gets 3. Then it does 3 and 3. So you can see it's going left to right. And it gets 6. 6 and 4 is 10. 10 and 5 is 15, and then it prints out the result at the very end. Now, I'm sure we have some functional programmers in the audience who are probably thinking, there's extra code here. We can make this even smaller. And you're right, we could. So let's look at an example of making it even smaller. You could import the add function from the operator module. And now we've got this down to 3 lines of code. Functools.reduce, add, and then the iterable. And the results will be exactly the same as the previous one, except I don't have all those print statements telling us what it's doing. We just have the result of 15. So, it's fun. You can play around with it and use it. I don't think I've actually used reduce in any of my code, but I can see why it would be handy in certain situations. All right. Let's continue to function overloading. You may not know this, but Python actually has the capability to overload a function. And the way you do that is with the Functools module. What is function overloading anyway? It is a generic function. Yeah, I don't really like the way I wrote this, but I'll try to make it clearer without reading it entirely. Okay. So function overloading, basically you have a generic function that is composed of multiple functions implementing the same operation for different types. It's really kind of weird to think about. Basically, you have a function that is kind of like the fallback function, or almost a type of its own, that you will fall back to if you don't register the other types to it. Which implementation should be used during a call is determined by the dispatch algorithm. Now in Python, dispatching is based on the type of the first argument of a function. This is different than C++. And I'm sure Java does it differently and other languages do it differently. But I know in C++, their function dispatching algorithm can look at multiple arguments in the function. So it doesn't just look at the first argument. It can look at all of the arguments. And so you can have pretty complex function overloading in C++ that Python just doesn't support out of the box. All right, let's take a look at using functools.singleDispatch. Let's see here. Got to grab the right example. I'll scroll up here to the top. So you import it, and you'll notice that this one is back to being a decorator, whereas reduce and partial were both functions that took other functions. Now we're back to decorating functions. This one's kind of interesting. So let's talk just a little bit about what a decorator is, because I think it'll make it a little bit more clear what's going on. So a decorator takes in another function and modifies it slightly. Well, it doesn't modify the function itself, but it can add functionality. So you might add some logging to it. You might add some authentication to it. In this case, what we're going to do is we're going to make this add function be overloadable, so to speak. So it takes 2 arguments, A and B, and it immediately raises a not implemented error. So this function isn't very useful by itself. However, when you want to overload it, you create another function named underscore with the same arguments, and you register it with the name of the generic function. So you'll see here, instead of @singleDispatch, you have @add.register, and then whatever type you want to register. So in this case, we're going to register int, and we're going to print out inside of this function, we're going to print out the type to verify that we have it working right. And then we'll just add it together and print that out. Down here, we'll go ahead and register the string type 2, and you can see this function is also named underscore. Normally, in Python code, you can't name multiple functions the same, or you'll end up with some kind of syntax error or a runtime error even. You just have all kinds of weird problems. Because we are registering them using this special syntax, Python is okay with it. I went ahead and created 3 different functions. I went ahead and created a list one as well, so it'll take in one list and another list and then add them together, basically. There are other ways to do this, of course. I just decided to do it this way. And I think we'll just play around with this a little bit and see how it works. So let's try running my single dispatch code. And you can see that by passing in a list of 1, 2, 3 and a second list of 5, 6, 7, it calls the correct method because it says class list here, and it's going to use some chicanery to add them together. Now let's see what happens if we try to do tuples. Let's try passing in 2 tuples. Oh, we got that not implemented error, unsupported type. Now where is that coming from? That comes from up here in our generic function. So because we didn't register tuple in here anywhere, we're going to get an error. Now we could grab this code and just create a function. We can call it tuple or register tuple. Then, well, let's see if it works. We may end up with another error because can you add 2 tuples together? I guess we'll find out. Let's run this. Aha. So we run our tuple code. Now we don't get the not implemented error, and we get a tuple with the contents of 1 and 2. Now, just to be clear, tuples are immutable. So what's happening here is we're creating a third tuple that has the contents of the 2 tuples combined. Anyway, I think this float one will also fail because we don't have float figured out yet either. Yeah, we also get a not implemented error because float is not supported. We don't have float registered here. I've seen, I think, one instance in my career where I think single dispatch would have helped clean up some crazy code I was working with. And hopefully you're starting to see how you might use it in your own code, which is like simplify some complex logic. I've had to do it with basically what amounted to complex configurations. One configuration type might be a type of machinery. So I used to work with precision agricultural products, and we'd have to load configs for like a planter and a combine and a sprayer. And each of those types were different and could be built differently. And one of my ideas for cleaning up that code and making it a lot easier to follow was to use single dispatch to dispatch to the functions appropriately to build the configurations. I never did get that quite working the way I wanted it to, but it would have worked really well if I had been able to tweak it and had the time to finish messing with it. All right. I do want to mention that just because Python doesn't come with multiple dispatch out of the box, it doesn't mean you can't do it. There are actually at least 2 packages that claim to support multiple dispatch in Python. I keep seeing Plum mentioned on Twitter. I've had several people contact me and point out that Plum exists. Strangely, their examples don't actually show multiple dispatch. At least I haven't found one yet. They all mention one. All of their examples show like one argument being passed to it. But I mean, the whole title is multiple dispatch in Python. So if you played with Plum and seen it work, that's awesome. I think this looks like a really cool project, and I'd like to play around with it some more. Interestingly, this one mentions multiple dispatch and compares it with multiple dispatch, which is the other package you can use to support multiple dispatch or multiple overloading with Python. I'm not sure how this one differs, except that it's using a decorator a little bit differently here. Its decorator is where you pass in the types for the arguments that are getting passed in. So, add takes int here, and this particular add takes in object. So you can differentiate between them that way. This one looks more promising to me than Plum does, just because the examples actually show multiple dispatch in action. But, I haven't tried either one of them. So if you try them out, let me know how it goes. All right, so functools.wraps. I think this might be the last function I want to talk about in Functools. I have a really short tutorial on how to use this appropriately in Python on my blog. Feel free to check that out if you have a moment. Otherwise, whoops, went too far. Otherwise, let's take a look at an example. All right. So here we get to talk about decorators again. Here's an example without using the wraps method or decorator. Here we're creating a logging decorator. And if you've never seen a decorator before, I guess I'll have to break it down for you. So to create a decorator, the normal way to do it is to have a nested function inside of it. The outer function takes a function as its argument. The inner function takes the args and keyword arguments that go to the function that is being wrapped. In this case, I'm going to log the args and keyword arguments out to standard out. And I'm also going to print out the result of calling the function. And then typically when you're done calling the function, you return it, and then you return the actual wrapper function in your decorator. Then to apply your decorator, you just do at whatever the decorator name is. In this case, we're calling it logging decorator. And we'll keep using this add function that we've been doing. Then down here to test it out, I do something kind of odd. Here we're going to try to print out the add function's name using the dunder name method or dunder name attribute. We're also going to print out its docstring using dunder doc, dunder being double underscore doc. For those of you who've done this before, you're probably going to know what's going to happen, but I won't spoil the surprise for those of you who don't. So let's go through this. You can see where the args 4 and 5 got passed through. I didn't pass any keyword arguments. The result is 9. Name of function is wrapper. Wait a minute. The name of the function should be add, not wrapper. What is happening is that our decorator is getting replaced with wrapper, which you can see right here in the code. We're returning wrapper. We're not returning the function back. So wrapper replaces add entirely as far as Python is concerned. And so you end up with the name of the function being wrapper and the docstring being wrong as well. This can lead to some really frustrating head-banging debugging sessions. You're like, where's my code wrong? Is it in this? Is it in my add function? Where is it? And depending on how you're logging your code, it can be really squirrely trying to figure that out. I've also heard if you don't fix this particular problem, PyTest will get angry too, and you'll end up with some weird issues with PyTest. Maybe they fixed that since the last time I've heard about that. Anyway, it's easy to fix. You can use wraps to come to the rescue. So from Functools, import wraps, add at wraps inside of your decorator, and pass in the function that you're decorating to at wraps. So now we have our own custom decorator with a decorator inside of it, inside on the nested function wrapper. All the rest of the code is the same. So I shouldn't have to explain that again. Let's go ahead and run this. So now we run it. The name of the function is now add, like it should be, and the docstring is now correct, a function that adds 2 values. That's all there is to it. Import wraps, slap it in your decorator. Make sure you put it in the right place, because if you put it up here, it's not going to work right. It has to be nested along with the wrapper function. And that'll fix the problem. As long as you remember to do that, you should have a much better time debugging your code. All right. So today I've covered Functools pretty much in its entirety. We've talked about caching. We talked about total ordering, partial, which basically creates partial functions that you can use to replace a Lambda function if you want to. Reduce has been hidden in Functools, whereas before it was available everywhere. And it's a really handy tool if you need that kind of functionality. Single dispatch is for function overloading. And you learned all about that. And you also learned about Plum and multiple dispatch packages. So if single dispatch doesn't do everything that you need, you can rely on those external packages. And lastly, we learned about wraps, which is, of course, for fixing up your decorators. I believe that's all for my presentation. So now I can take any questions you might have.
Hey, thank you so much, Mike. I was just monitoring the chat, and we have a few questions. The first is, what are the effects of using these kinds of functions with PyPy? So, for example, when you're using total ordering or partial, like, did you ever notice any change in performance? Was it positive, negative?
I haven't done a lot with PyPy, but I believe it should work just fine in PyPy. I don't think it's going to. I mean, PyPy is already faster than regular Python, so I don't think it's going to be make PyPy slower than regular Python would be,
All
if that
right.
makes sense.
Yeah. I mean, my initial idea for that is that PyPy also doesn't support tail end recursion, if I understand
Oh
correctly.
yeah, yeah, I
So
remember
so
that.
there shouldn't really be much of a change in terms of performance. I mean, it should be faster, but you're already using different functools methods and functions to optimize your performance, so it shouldn't make that much of a difference.
Yeah, I
Okay, so
agree.
this one is a really good one, which is, can I use cache or LRU cache on async functions? I would ask you a further question. Would that be a good idea?
I would ask that too. Um, I've never used it on an async function, so I don't know the answer to that one.
But why
Um,
wouldn't it be a good idea though? Like, what could go wrong?
hmm. I'm assuming you have an idea because I actually don't at the moment.
I mean, if you're trying to optimize for performance, and if it's a, you know, if it does some compute,
Hmm.
then yeah, I don't see much of a change. But for example, if the way that async works is that it executes and then it goes on to something else, so there's a lot of
Hmm.
time sharing, and I'm just worried what that would mean when you're trying to you know get the response from a function that is kind of order dependent.
Oh
Um
yeah,
yeah, so that would be a quagmire for sure.
yeah. That makes
So
me
that
really curious. I might have to go do some research on that.
Yeah, maybe you can blow up a few things and we can have another webinar. This is a person who asked about the LRU cache. Have you ever had an issue with the max size of the LRU cache not being respected? So, like, you would set a max size to like 100 or 200, and then what would happen is that it would go over the max size. You would get like, I don't know, a memory leak of some sort, and then your computer or so your application would crash and would need to
Mhm.
be restarted. Have you ever had an issue like that?
I personally haven't. I mean, I guess I could see that happening if you're like running on a Raspberry Pi or something, and you try to download too much data or try to use the function too much, and you just end up hitting that, and then you just have to tweak your cache until you find the sweet spot for that
Mhm.
type of machine.
Yeah. So just a clarification on the initial question that we had with PyPy, what he wanted to know, what Carlos wanted to know is PyPy without any caching, just your regular stuff versus Python using cache and functools and other things. And I don't really
Mm.
know if that is a fair question, because if something is algorithmically superior, it's supposed to be faster. I don't know. What would you say?
I would agree. I personally haven't played with PyPy enough. I've done some little tests with it, but I never was able to convince my bosses to give it a serious try. So
Yeah, I mean, it would be interesting to use PyPy more in production applications.
I agree.
Um, um, so this is a question for me. This is something that I was curious about, because, like, if you go back to your code, and if you take a look at the way you do single dispatch in functools, you have like
Hmm.
a function, you add a decorator on top of it, and then you add a couple of functions that are basically underscores. Is there a
Hmm.
way to kind of put this in a class and have that be called? Because it just feels neater to me, instead of having a file and on the top level you have like functions and underscores and decorators all throughout.
I've never done a huge deep dive into that, but can you use that in a class? A good question. You would think you could, but I'm
Hmm.
assuming you do it on the methods.
Yeah, it's more of a aesthetic thing, I guess, more than anything else. I mean, single dispatch on in a normal Python file and everything top level works, but it just looks kind of weird.
Yeah, it looks like, and this is what I would expect, you could definitely do that in a class instead.
Hmm. Okay,
Yeah.
yeah. So you'd basically treat them as, oh, you'd have like a class, create an instance, and you keep calling it.
Yeah, I believe that would work. You probably might have to do just a smidge of meta programming, but I think
Hmm.
looks like that. I think it looks like there's a way to make it work.
Yeah, I'm just thinking whether you'd classify them as class methods or static methods, because in this example, it seems like they're instance methods.
Yeah, right now they're instance methods. You might have
Yeah.
to. Yeah, I haven't actually tried that. That's also a really neat idea. Hmm.
And yeah, so Christian Muller says, can you implement the class as a callable to make this work? I guess that is what you would have to do, um, if you wanted the ergonomics. I think what me and Mike were talking about was more like, having static methods on a class body and reusing those methods.
Hmm. Yeah.
So yeah. Okay then. I guess that's all the questions that we have for today. Thank you, Mike, so much for joining us, and hope to see you again soon. And before we wrap up, we just have some information. If you'd like to follow us on PyCharm, you can do that on Twitter at PyCharm. You can also subscribe to our YouTube channel. You can also follow Mike on Twitter at Driscollis. He's also available on GitHub with the same name, Driscollis. And please don't forget to like and subscribe the video. We really appreciate y'all showing up here. And if you want more of these, please subscribe so that we know that this is something useful. So that's it. Thank you so much for coming, and see you again next time. And thank you, Mike, once more for joining
Yep.
us.
Thank you.